All right. Hello, I'm Evan, and today I want to share with you my implementation of the Sickly Wizards Blender 2D rig in the Unity game engine. Here in my Unity project, as you can see, I have my character model, Alice, and she's animated into Blender with the rig created by Wizard. And as you can see, if I go into play mode, hopefully she will be animated. And yeah, her face, as you can see, is animated pretty. Yeah, it's pretty cool. Yeah. As you can see, this implementation supports texture swapping, UV offsetting of the UV maps, and UV maps scaling. There are three main protagonists in this system, and we will go through each one. Firstly, the face has a face material with a custom shader. As you can see, if I go into the materials folder, no, not this one, I have this custom face shader that is right here. This shader basically replicates the. Oh yeah, I should probably tell you about my rig in this case, because it's a little bit modified respect to the Sickly Wizards one. So yeah, the Blender's rig is a little bit different. I have made some modifications. I'm using Rigify because I don't fucking know how to make controls for rigs. So yeah, I'm using. And as you can see, the orientations for the faceted bones are a little bit different. But you have your usual bones, UV pupil transform, UV pupil.L, UV pupil.R, and the UV pupil master and the UV pupil base. I would suggest you to create your faceted bones in this orientation, so the UV pupils pointing forward and the UV pupil transform pointing up, because I set my system with this setup, so I don't know if it works with the Sickly Wizards one. And I don't want to check. These bones have all the goodies that the other rig has. As you can see, we have this the scaling and the transform. I made some limitations. I simplified the system a little bit because I didn't need all these features. As you can see, I still pose the mouth and the eyes through the custom property shader thing. Yeah, I don't have controls for the texture index because I really don't need it, and it's just overcomplicated for me. But as you can see, it's basically the same thing as the Sickly Wizards. You have your UV pupil master that controls both of the pupils, the UV pupils themselves, the UV pupil transform, and the UV pupil base that is used to calculate the relative position of the eyes. What's more important to this mod and to this rig is the faceted bone, this bone right here. So what am I doing here with this bone? What is it there? Yeah, so basically Unity supports animated custom properties, but it's so badly documented and it's just broken. Even if I have animated custom properties enabled here and I export the model with animated custom properties enabled, Unity still can't see any curves at all and any animated properties at all. So I had to figure out a workaround because I didn't want to spend 3 days figuring out why it wasn't working. And I just think to smash the texture indexes data inside the face state bone. So this bone right here is, it's called face state, and basically its X location and Y location are driven by the texture indexes. As you can see, the X location is driven by the eye texture index, and the Y position is driven by the mouth texture index. What this lets me do is just basically, I can still animate the face with the custom properties and have it shaded correctly in the shader tab, since it shades the model just like the Sickly Wizard setup. But I still have my data exported to the face to basically plunge into the fucking faced bone that I can read later into Unity and use it. As you can see, by playing the animation, you can see the faced bone moving around and doing this stuff. I also crammed a little bit and chipped out a little bit on the UV maps. As you can see, if I go into the UV maps full section folder, I have a total of 5 UV maps. I have the base UV, the eye UV, the pupil.L and pupil.R, and the mouth, because I'm using a 2D mouse. I crammed down the both of the eyes UV maps inside just one, because I didn't need individual. I don't need winking or that sort of stuff. So I just put them together to save on UV maps, because as you can see, we can only have a total amount of 8 UV maps, and that's also the max amount of UV channels that Unity supports. So yeah, with that said, we can actually go and take a look at the shader, the face shader. This shader basically replicates for the most part what is being done here in the shading tab in Blender. As you can see, we have a lot of hidden in inspector properties. These are all hidden in the inspector, because we're actually going to set them up later in the face material manager. But yeah, these setups, the UV core, the UV channels and stuff, and basically the most important parts are the vertex shader and the fragment shaders, which are very, very simple. Also because I'm using flat shading without unlit shading, without any sort of lighting, but you can probably implement it in it should be fairly simple. I don't know. I don't want lighting in my model, so I'm using unlit shading. You can use lightning shading. I don't know. It's your face, man. But basically, in the vertex shader, we're doing all the offsetting and texture choosing and stuff. As you can see in the pupils UV channels, we are doing the offsets and calculating the local position relative to the UV pupil base bone. In the eye texture UVs, as you can see, as you will see later, we will be using a texture atlas to use the eyes textures and the mouth texture, because doing a hot texture swap at runtime in a game is not that performant. In Blender, it does not take a hit on performance, because yeah, it's a render, but in Unity, it can actually be, it's not the best thing. So we're using packed textures atlases, or whatever they're called. In the fragment shader, we're just mixing the textures together based on the UV channels and outputting a final color, which is basically the face. Where is it? The face. Okay, so we can move on to the face material manager. As you can see, the face material manager is on the main model here, and it has all sort of goodies. Let's go through all of them quickly. We have the face material reference, which uses the face shader. We have a lot of bones. These are the bones that animate our face, and we need basically the face material manager acts as a middle ground between the face shader and the animated face bones. It will take the face bones as input, and it will control the face shader through the face material, so it can be animated. We have the UV pupil base bone. You must select the original bones. I'm using Rigify, so basically I just set it. If I go into here in the meta rig, I can actually show you how I set it up, each of the bones. As you can see, each of these bones is set it as deform, because when I go to export the model, I actually use the only the form bones option, so it doesn't export all the widgets and controls and stuff. So they're actually all the form bones, but you want to use the original bones, because the form bones get, I don't know, they're pretty weird. But basically, yeah, I'm just setting the original bones right here. This UV offset, as you can see, is just the same as the UV offset in the UV warp section right here. Offset 0.05. The faced bone that we created earlier, and the textures. As you can see, we have the eye face texture, which is an atlas, and you're gonna say, I don't want to create a texture atlas anytime I update my textures, and well, I got you on that, because I created basic. I glued together a fucking texture packer. This is very simple. This is a Python script that basically takes all of the textures in a local folder takes the prefix. For example, this is mouse. It's gonna add the atlas at the end, and it's going to generate our texture atlas. You can import these atlases into Unity, and I've done that already. And what you want to do for both of them is go into the advanced section and disable the non-power of 2 to none, because otherwise, if your texture is, for example, 112 in dimensions, 112 squared, it will turn that into 128, and that is going to mess up later when we are going to choose the texture for basically the faces. Then we have the eye state cell size and mouse state cell size. This is just the what it's basically asking us what size is basically each texture of the texture atlas. In my case, the eye textures are 35 by 35 in size. As you can see, if I go in here, it's 35 by 35 pixels. And we have then the pupil L and pupil R textures. Okay, so let's take a look at what the Face Material Manager script is doing. Here we have all the references and all the properties keywords that are in the face shader. As you can see, these are basically some constant strings, so I can reutilize them later in the code. The invalidate section basically just checks if it basically setups the face shader in the inspector, so we can see the model even if we are not in play mode. In the late update, we are actually doing the magic right here. We are calculating the offsets for the pupils right here by subtracting the relative positions of the bones to the UV pupil base bones and adding our UV offsets. Here we are updating the face shader pupil offsets that we calculated earlier. We are also getting the UV pupils scale. Here we are using the face state bone locations as data for updating the textures of the eyes and the mouth. On destroy, just basically resets everything, and this is a shader update callback used by a class that I've made that is called texture atlas info. This class basically acts as an abstraction to the creation and usage of a texture atlas. And as you can see, it basically provides some methods and stuff to simplify the process. In fact, it has this function called update active texture, where you pass in a texture index of the texture you want to get from the texture atlas, and it will automatically update the shader and tell it, hey, you need to go to this UV offset of X and Y to select the right stuff and thing, and also going to calculate the scaling factor to properly choose the texture and stuff. Other than this script, we also need a third one. Basically, Unity fucking sucks and decides to ignore completely our concept interpolation and replace it with some shitty linear interpolation. Basically, when you import the model, I highly suggest you to disable animation compression, and I'm going to show you later some export setting for Blender that you might want to use to not hook up any problems. But basically, disable animation compression, and what you will notice is that the face state bone, even if, let's say, at a frame you have a value of 0 and the next frame you have a value of 3 on the X position, so you're changing the eye texture, maybe from an open eyes to a closed eyes texture. Unity will actually interpolate that and it will add middle values. The result will be flashing textures and flickering of textures before the final textures actually pops up, and that's very ugly. So watch the third and final protagonist of this setup is a face animation quantizer. Basically, this script just forces a constant interpolation on the animation. This is an asset post processor, so this will run every time you import an asset with animations, because it has a callback on the on post process animation. And basically what it does, it checks in any animation if it contains a bone with the keyword face state in it. If it finds a bone with the face state in it, it will basically just set the interpolation of it to constant right here. Okay, and that finally will give us our animated 2D face rig that we animated into Blender. So to actually show you how fast maybe of a workflow you can expect from this, I'm going to be creating a new texture for the eyes, and I'm going to create a new animation. So yeah, let's go into eye states. I'm going to open Photoshop, and I'm going to create, yeah, this is not what we want. Okay, so we have our new texture. We're going to export it right here as I.I004. Okay. We're going to run the Packer again, and we have a new texture atlas. So we're going to import it right here. Alice textures. We're going to open this up and get this new texture atlas in here. Place. Let's let it import it. Okay, so we messed up. Let's go into Alice. Let's check if the texture is 105. Let's update this. Okay, we have our new texture imported. Now let's go into Blender. Let's go into the shading tab and let's re-import our... Okay, this should refresh it. Okay, let's go into the animation tab. I'm going to choose my rig, and I'm going to go into pose mode. I'm going to create a new animation from the rest pose, so I don't get any animation data. I'm going to create a new animation. I'm going to make it last 50 frames. In my project, I have 30 frames per second, so yeah. Good to go at 30. I'm going to go into the... I'm going to add a little bit. At 29, I'm going to add everything, and then I'm going to go here. I'm going to... yeah, it's messed up, but I mean, it's good enough. Okay, now I'm going to show you the export settings that you want to use in Blender to avoid any problems, because problems are very easily found in this system. So what you want to use, I use limit to selected objects because I like to export only what I want to export. Armature mesh, custom properties, this doesn't really matter. But what is important is apply scaling's FBX unit scale, because if the scaling is messed up, the bones scaling will also be messed up, and the locations of the bones will also be messed up, and it will not work. Forward and up, you have to set them right. So forward and up, apply transform, and in bake animation, you want to put the simplify rate to 0, because otherwise some compression will happen, and yeah, it's not what we want. Also make sure we have our we have custom interpolation enabled. Perfect. Okay, Blender should have exported our model. Let's check it out. Models. All right, here it is. Now let's update it. I'm going to just drag and drop this in, replace the file. Okay, it should work. It didn't import the test anim, but it really doesn't matter because we aren't using it. Perfect. We're going to actually go to 50 frames. No, okay. Can't I go up? No. Our eye atlas is updated, and we should even get a frame of our animation working. I hope so. Let's see if it...
You are my sunshine, my...
Okay, we're back after fucking too much time. I just found out, yeah, that I was missing a minus right here, because obviously the offset on the Y is going down, so it's negative. That didn't give any problems when the texture was 2x2, but you know, yeah. But now check this out. Check this out. Check this texture out. Okay, perfect. So, not counting the 20 minutes of debugging and fixing right there, I think that workflow is pretty fast. It's pretty good. I mean, I don't think it gives too much hassle when it works. So yeah, this is my implementation. Thanks a lot to the Sickly Wizard for creating such an awesome system. And yeah, I hope you learned something new, that you might use this system in the future. I'm probably going to be making a full implementation with all the features of the rig. But right now, for the project I'm working on, it's really too much, and it's just complicating things without too much benefit. For anyone curious, I'm working on a psychological horror game inspired by the poem of William Blake, The Poison Tree. If you'd like to know more, I don't know, it's up to you. I mean, thanks again for watching, and yeah, I'll catch you in another one. Goodbye.